Hi, and welcome everybody to the session about architecture. I'm an architect by heart, and I want to share a little bit today about what I think architecture is all about and how it translates into architecting in the cloud, and specifically how it translates into being a solution architect. The reason I think this is so important is because we see a lot of success stories of what people do with cloud and many other technologies. And I firmly believe that behind every one of those stories is a successful architecture. Sometimes people experiment a lot with features and discover great services that make their customers happy, but there was an architecture behind it that allowed it to scale, so it could actually be used by all the customers, or that they could keep their velocity, so they could keep experimenting, or many of the other properties. So my name is Gregor. I'm an enterprise strategist at Amazon Web Services. What that really means is they're all strategists. We come from the customer side. We all led major cloud journeys, cloud transformations, cloud migrations ourselves. I've done so in the financial services industry, and I also spent a little over half a year at GovTech as a Smart Nation Fellow. We talk to a lot of customers, so we learn a lot, have a lot of interesting conversations. So I like to capture what I learned myself and share that back in the form of books. And not surprisingly, they're related to architecture and architects, and also to cloud computing. With that, let's start though, and let's look at what it means when we talk about being an architect. And I don't mean being an architect is something that you have on the business card, but I do believe that it's a certain way of thinking and a certain way of working. And I'm going to share a few aspects of what I mean when I say thinking like an architect. If you go on the internet and you look for architecture diagrams like software architecture, you're going to find stuff like this, right? And a lot of people expect a software architect to come up with these things. There's like databases and components, and they connect somehow, right? The web is full of these. A lot of whiteboards are full of these. Sometimes entire tapestries are full of these. But if you look at famous building architects, and we all know that the analogy doesn't hold in all aspects, but I think in this case it does. To look at what famous building architects do, they don't make those kind of blueprints. Famous building architects draw things like this, right? And if you want to get a hint, at the bottom right is a signature there. This is Frank Gehry, right? One of the most famous and most outstanding architects we have. Now, it's kind of interesting. They don't make these kind of blueprints that we've seen in the previous screen. They make sketches, right? And at first glance, you might feel like, well, I could have done that. Well, the short answer is no, you probably could not have, because this sketch in the end turned into this. Right? There's a Guggenheim Museum in Balboa, a very, very iconic piece of architecture, classic Frank Gehry style, world-class architecture. So this is something that Frank Gehry does. That is not something that you and I do. However, as software architects, we can learn a lot from this. Right? We don't need necessarily all these blueprints. We have tools that do that better for us, right? Because we assemble bits and bytes. We don't lay up bricks and cast concrete. But what we should be doing as architects is thinking about the overall gestalt and balance and overall shape of what we're going to build, just like Frank Gehry did. And he did take the context into account, right? This is very horizontal. This is by a waterfront, right? It's a traditional city, so you want something modern, something blends in. There's a lot of thought and consideration in here, but it's not a blueprint. It is something that makes a decision, has design integrity, and places an emphasis. So that's what we should be doing as architects. Now we should be making sketches, meaningful sketches, not these elaborate blueprints. Tools do that much better than we actually do. Now, not all of being an architect is drawing. Often it's also helping people solve problems. And I'm sure many of you have been in situations where people argue back and forth, whether it's about their favorite programming language or whether the system needs to be designed this way or that way. A lot of times architects come in as tiebreakers. Right? People say, oh, let's go talk to the architect, what he or she is thinking. And one of the reasons architects are good at that, if they actually think like architects, is because we often see more dimensions. And this is a classic example, one of my favorite sketches, right? One person looks at an object from one side, another person looks on the other side. One proclaims it's a circle, the other one proclaims it's a rectangle, and they can go at this until the cows come home. So architects often realize there are more dimensions to this. And in real life, this could mean that a component really should be broken down into two, that concerns that are seen as a single thing are actually a function of independent parts. There's many ways we can add dimensions. We can also untangle things like speed and quality. Like a lot of people think that's a single dimension, go faster, get poorer quality. Not true at all. These are two independent dimensions. So architects often see more. They don't have this sort of left or right, black and white, circle or rectangle kind of view. They see what's behind those, and they can see additional dimensions. And sharing that back with the teams can unlock some of these discussions, and it can lead also to better decisions. Now, very related to this is not just seeing more dimensions, it's also seeing things from different levels of abstraction. We zoom out and we zoom in. And important here is this is not like a camera zoom where you sort of see the same thing, just a little bit bigger, a little bit smaller. It's more like this Mandelbrot set. Right? When we zoom out and we zoom in, we see very different things. We might see business architectures and trade-offs and go-to-market strategies. And then we zoom in, we might see architectures for resilience. And we zoom in further, we see like Helm charts and YAML files and missing commas and curly braces, right? Because something isn't working. Right? We see very, very different things at the different levels, but being able to connect those levels is one of the key things that architects could do. And me personally, I could be watching these animations for a long time. Yeah, maybe that's also part of being an architect. So you need to be able to zoom in and zoom out, see things at different levels. And there's the last one that architects need to do to think like an architect. And that is, I ask myself, when do we not need architects? Actually, a good question. You should always ask yourself, if you have a certain job, when is it not needed? And I believe for architects, that is the case if there is no rate of change. Nothing ever changes. You sort of somehow glue the stuff together. It kind of works. You leave it alone. Now, luckily for architects, that's a very poor assumption because something always changes. The scale changes, right? Things need to scale up under load, right? The requirements change. Things need to evolve. Platforms underneath change. Like everything changes. And the more things change, the higher the rate of change, the more important your architecture becomes. One chapter in my book is about how architects sell options. So I invite you to have a look at that and see why these options become more valuable under high rate of change. And it also highlights to you why we essentially live in the first derivative. We look at how things evolve over time, which things move more quickly, which things maybe move more slowly. And that's another important part of thinking like an architect. So there's quite a bit of sort of what makes an architect, right? You make sketches, you see things in different dimensions, you zoom in, zoom out, and you live in the first derivative. And maybe at first, take that sounds a little theoretical, but actually it translates very, very well into concrete examples. One concrete example is, of course, cloud architecture. Cloud platforms can do amazing things for us, right? But they also come with their own architecture trade-offs. So we can see how many of these principles apply. Now, the common theme that I have here, and it's very related to the zooming in and zooming out, is what I call the architect elevator. Yeah, you guys know that traditional organizations, either it's public or private sector, we tend to have many different layers. And layers are helpful because they bring us separation of concerns, they bring us abstraction, they bring us replaceability of layers, great architecture properties. But they also bring us friction and sometimes translation errors, right? If things have to go through the different layers, right? One person higher up said something, by the time it comes down to the person configuring the Helm chart, right? They have little idea of what was actually originally needed. And that's not a very good thing because that means what the work is actually done might not support the either business goal or the overall strategy or objective. And if those two are out of whack, your best technical solution actually isn't very valuable. So connecting this is important. Now, what you can't do is just get rid of all these layers. I always say if you take a few floors out of a high riser, you don't get a bungalow, you get a pile of rubble more likely. So you can't do that. But what you can do is put a new elevator in or attach an elevator to the site like they do during construction and have the architects write this kind of elevator up and down. So when I talk about cloud architecture, I want to use the elevator metaphor. And actually we start at the top floors. Because if things aren't lined up there, as I said, everything else will not actually save us. So what does it look like to be a cloud architect up in the penthouse, up in this sort of strategy that we're pursuing? And I always start with the role of IT. We are in IT, we deal with technology. We try to provide technology either to support the business, or making citizens' lives better, right? Or pursue research, whatever the purpose might be, right? We bring technology to achieve a certain goal. And in the past, that technology has been important. It's always been critical on the horizontal axis, but it hasn't so much of been a differentiator. So I worked in a large insurance company, and we spent many billions of euros on IT. I mean, very well spent, actually. But what we did was largely, what did we do, right? You built actuarial systems, notifications of loss, claims handling, risk calculations, compliance reporting, payroll, right? These are all things the insurance company would have done 130 years ago, because actually 130 years old company, right? These are all things the business would have done anyway. We just made them faster and more accurate and cheaper, more reliable, more precise, right? All these kind of things, but essentially they were what I call digital copies. So that made us a commodity, an important commodity, but not a differentiator. Now IT in so-called digital companies is very different, right? They use technology to redefine what it actually means, right? Amazon started as a bookstore. Well, we redefined a little bit what a bookstore is like, right? As an online bookstore, and the technology is inseparable from that. And when we talk about cloud architecture and cloud strategy, that transition is actually at the heart of it. If this transition doesn't take place, you're unlikely to get the full benefit out of the cloud platform and all the great stuff that it brings. Now, the reason that is because this operating model is baked deeply in the way IT works. And I know many of you guys know that because I used to sit at all the same steering committees. Well, how does things get done in IT is like, well, you make a business case. Based on the business case, you start a project. And when the project is done, you return to business as usual. Well, actually worked reasonably well, worked at GovTech, worked at Allianz, right? But there are some important assumptions baked into this. And one of the assumptions is you have a good idea what you're going to build and the benefit it's going to achieve, because how else are you going to make the business case, right? You need to somehow calculate what's going to come out the other end. And the other assumption, of course, is that change is temporary. You can package the change into the project, and when the project is done, comes the sigh of relief, business as usual, no change. Now, in the so-called modern cloud-enabled digital world, both assumptions are no longer true, right? Because if we want to be differentiator, we need to experiment. We need to find new business models. Now, how do we know which business model is the best? Well, the real answer is we don't. We need to experiment. So we don't know exactly what the business case is, and we can't expect our first experiment to be the home run. So we need many experiments. So that also means change is now the usual state as opposed to the unusual state. And I call these the economies of scale. Build something, reap the rewards. The larger you are, the more return you get, versus economies of speed. The faster you can cycle, the more successful you will be. Now, not only are the skills required very different, right? Left is about planning and execution and forecasting. Right-hand side is about learning fast and improving quickly. You find that organizations who make this transition also speak a different language. So language is a reflection of our way of thinking, our culture. So when you make this big shift in thinking, you will find that folks in IT also change their language. Now, they don't change it from English to something else, but they use a very different vocabulary. The left-hand side speaks in absolutes, right? This is what these steering committees in these project proposals look like, right? I need like $5 million. Yeah, it's going to be 12 months or 18 months project, right? I need 15 headcounts, some externals, and I need to buy hardware for a couple $100,000. So here's the use case I'm going to do, and here's the payback and the return on investment. That's how these committees generally happen, right? It's all absolute values. The folks on the right-hand side, they're always on the move. They're always changing, right? We just said change is normal for them. So these absolutes aren't as meaningful. Like maybe halfway down the line, I need more than 12 people, right? Like maybe I need more money, maybe I need less. So they speak in rates. They speak in relatives. You might say the first derivative, mathematically speaking. It's a great fit for architects because that's where we live. So the projects have a burn rate. They cost you $30,000 or $40,000 per month, right? You have a certain velocity, like this is how much business value or many feature points you deliver per agile iteration, per agile sprint. And you don't buy hardware for $200,000, right? You get the server for $2 an hour. And this is the simple reason that essentially all organizations on the right are in the cloud, because the cloud matches the model of the economies of speed. Now, this highlights, though, how big this difference and how big this jump up in the penthouse is, right? And that's your first job as an architect. And once you have done that, or maybe one of your colleagues has done, then you can go down one level and talk about building systems to satisfy this need that we identified up in the so-called penthouse. Now, there's a lot to be said about building systems that can do amazing things. So here, just a short sample, right? One of them is we say software can do amazing things. It can defy the laws of physics. Because normally, if you want to experiment, we need to move faster, economies of speed. What we know is that you move faster, consumption goes up. Even electric cars have that problem, right? The faster you go, the shorter your range will be. Now, software has a few tricks up its sleeve, right? We can actually move faster at lower cost. And there's many reasons we can do that, but probably the most sort of important one, the most showcase one, is that we make smaller pieces. Right? And when I say smaller pieces, I mean 3 separate dimensions of making smaller pieces. We make smaller software artifacts. Keyword is microservices, right? Smaller pieces that you can deploy independently, easier to roll back, smaller blast radius, many advantages you have, independently scalable, but you also make smaller teams, right? These can be tribes, this can be feature teams, agile teams, whatever you want to call it. We call them 2 pizza teams, right? You have smaller teams and you have smaller timelines, right? These are your agile sprints or iterations. So you have 3 dimensions at which you shrink things down. Now, architecture is the business of trade-offs. So when we see this, we're like, oh, this is great, but we do know there is a problem with this if we don't watch out. And the problem is, or the potential problem is, that organizations are built on the principle of optimizing locally. And again, this makes good sense. Just like the layering, optimizing locally makes sense because it's easy to have the metrics. You have one person who's responsible. They have the necessary control to optimize. So each department makes sure they're well optimized. Now, there's one catch with this model, and the catch is that the sum of local optima is rarely or never the global optimum, right? You're just adding up some sub-optima. And usually we did okay with that. We know this. This happens when you go to some office and you need to take a number and wait for 3 hours, right? In some countries, that happens when you go to the doctor because they highly optimize their processing. But then, of course, they cause pain further down the line or further upstream. So that is an example of local optimization. Now, if we keep this principle and we make smaller pieces, we make the problem much worse, right? Because now we're optimizing more small pieces, and that actually works against us. So the architect view on this, making smaller pieces is great, smaller software, smaller iterations, smaller teams, but you need to keep an eye on optimizing end-to-end, right? And that's you can do with automation, increased transparency, setting overall business goals for what you're building, right? Taking the friction out of the system. There's many things we can do as architects, but we keep a keen eye on balancing the 2 things. There are a lot of people running around talking about microservices and everything should be in small pieces, right? As an architect, you can zoom out a little bit and you can understand that there's an organizational aspect matching to that and make sure that those stay in balance. That's a great activity for an architect to do at the mid-levels. Now, the reason you can do this, right, or the question mark, let's go the other way around. Smart people will say, well, why didn't we always work this way? If this is so great, we should have done this 20 years ago. And the simple answer is we didn't have the tools, right? You need tools to work in this way, right? And these are the tools that the clouds bring, that AWS brings, right? It's the software economics. You have low friction. You can deploy software easily and quickly and cheaply, right? So if you have many components, that becomes easy. You have high levels of automation in the platform. You have full transparency, as I already mentioned. And of course, you have the data and analytics to understand A, that everything is working, and B, whether it's actually achieving what you were set out to do. So the cloud is the one that brings you those capabilities, right? And we as a cloud provider know this very well. That's why we have the broadest set of services to make sure you have all these pieces covered and you can work in this great new way of working. and bring your architectural thinking to bear. Now, this is probably a good time to go down in the engine room and look a little bit like, well, what do these architectures look like in detail, right? We're still kind of interesting models, still maybe a little bit abstract, but very important. But let's get a look at like some tech, like some software architecture. Yeah, and one of the key things architects need to do in the engine room is make stuff not break, right? Nobody wants to pay for IT that doesn't run, and the customers or the citizens are also not happy if things are not working. So what do we traditionally do? We make systems that are robust. Robust is great. Robust means stuff doesn't break. And it's great until it actually does break, right? And then we need to think about, well, what do we do if it actually not working? And that's where we transition, again, a major jump. We go from robust systems to resilient systems. Very different attitude and very different architecture. It doesn't mean we don't want to be robust. We do want to be robust, but we know that's not sufficient. So we transition to also be resilient. As you can see here, the approach is very different. Rather than preventing failure, you will get good at recovering from failure. Rather than planning and verifying upfront, you build in redundancy and automation. And most importantly, rather than just relying on infrastructure, like buying better hardware and buying more hardware, you now also rely on the application, right? You have state replications, intelligent load balancers, many things the application can do to become resilient. Now, if you can deal with failure pretty well, you can do a very interesting thing. You can actively inject failure, because if you're good at dealing with failure, why not, give it a try and make sure that you are actually resilient. So to assure your resilience, you can inject failure. And that leads to something that Nassim Taleb more cleverly called anti-fragile, something that benefits from disturbance. So on the left side, we try to avoid disturbance. In the middle, we kind of handle it. On the right-hand side, we actually embrace disturbance. We're like, yeah, bring it on. The more failure, the better. And again, you see it's a very different approach, right? Now it's designed for failure, and it's a systemic approach. It's not just infrastructure and applications. It actually involves ways of working, teams, attitudes, processes. Like you need to combine actually the whole thing. I think this is a great way to show how in the cloud, right, we can be on the right-hand side, we can inject failure, and that's in the end how we get systems, ironically, that actually don't fail. Because the great thing about always being in a failing state is that if something fails, nothing changed, because you were already in a failing state. So this is one great example down in the engine room, how we build very different architecture, but you can also see that this seemingly very technical topic has aspects that relate back to the elevator, because it also relates to ways of working and ways of organizing and managing teams. Now, here is a great example of injecting failure. I have two favorite examples. The one is the fireman, because it doesn't burn that often, quite honestly. So they polish the trucks and they play cards, but they do one more important thing. They place a fire, right? Because you don't want to have the fireman who sees the fire the first time when it's at your house. You want them to know what the fire looks like and how it's being put out. So safety critical professions who know very much about anti-fragility, they know how to inject disturbance. Now, these guys here in the picture, they're doing this in the pre-prod environment, and I'm quite happy they're doing this in pre-production. In software, we can do this in pre-production or also in production, because software is actually a very special thing. So think about injecting some failure, make yourself more resilient. The key word that I've mentioned a few times and that always comes up in this is automation. And when we traditionally think about automation, we think about just streamlining manual processes, right? Like something that was done by people, we now do more efficiently by machines. And sort of the side effect also seems to be that we need maybe fewer people. And that was perhaps true for the Ford Model T, it was like 100 some years ago. It is not actually true for cloud software. We have very different goals for automation. We want to go faster, right? Because speed brings us many things. Speed allows us to experiment. Speed is important for security, right? If there's any problem, any exploit, you want to make sure it gets fixed quickly. It brings us uptime and resilience, as we just saw, right? If it takes you like a month to get back online, you're certainly not resilient. So speed is very important. Of course, we don't want to compromise quality, so automation allows us to be fast and high quality. And it turns out that automated solutions do both better, because the biggest source of error, unfortunately, is us. So eliminating us from some of those fast processes like builds or failovers or detection of problems actually improves quality while it improves speed. It does more important things also. I'm a big fan of continuous integration and automated builds. I use it for my books, I use it for my software. And the main reason I like it is it gives me confidence. I don't have to say my little prayer, whichever one you want to do every time I try to build the software or render the book. I know it works because it's repeatable. So I don't hesitate. I just do things. I know it's not going to break because I have done it 1,000 times and it's fully automated and repeatable. So confidence is a great thing because confidence in turn speeds you up. If you hesitate, you'll be slow. And the last thing that automation does, also often underappreciated, if it's automated, it's measurable. And if it's measurable, you can improve it. So it's another great benefit because you know how long each part takes. Last one I have out of the engine room is a great ility. And we talk about architects talking with ilities, right? The non-functional requirements, it's like the scalability, maintainability, portability, right? Those kind of things. Well, there's an ility that I think in the cloud that we can have that traditionally has been underrated, and that is disposability. So it's like, in this case, it's environmentally friendly because we're only disposing bits and bytes, but automation allows us to recreate things very easily. Like a server is wrecked or a piece of software goes away, we can recreate it easily and painfully. Gives you huge benefits. It takes fear away. It gives you confidence because basically like, okay, fine, that thing broke. I'll just make a new one. I move on. No big drama. But it also gives you consistency because the fresh component is always in a defined state. And that is great for security. That is great for reliability. And that is great for uptime. And so I don't get in trouble. It's not just Lenovo servers we put in the trash can. This applies to any hardware. And of course, we don't do it with physical hardware. This is all possible in the cloud because everything is virtualized. So it basically costs you nothing to dispose of it and recreate it. And it puts you in a well-known good state. So I invite every architect in the engine room, think more about design for disposability. It is an amazing thing to have. Now, so much to do with architecture, right? So like we're up in the penthouse where we look about the role of IT, we look at the mid-levels, and then we look in the engine room where we build anti-fragile, resilient, and disposable kind of systems. Now, obviously at AWS, we do a lot of cloud architecture and we do it with our customers. So we have a specific role for these kind of architects. We call them the solution architects. And at Amazon, we like tenets that kind of like our operating principles. So solution architects also have tenets, right? And it's always good for us to look through these. And it's like, yes, the customer best interest comes first because the customer is not happy. Basically, nothing else will save you. It's sort of like the penthouse, right? We like to work backwards from the customer's success, right? Of course, we're a business, so we also need to make sure this is viable for the customer and us. Architectural integrity, make sure it's a good solution, a well-rounded solution. We have a lot of architects. So we like them to share what they know. We don't want each person to sort of reinvent and learn everything from scratch, right? We have the huge benefit that we've done this thousands of times. So we have a shared body of knowledge that these architects work across. Right? There's many things like platform improvement, right? A solution architect is not a one-way street, right? You provide solutions to the customer, but you also bring ideas and suggestions back, like real-life solutions that the customer are the best ideas to bring back into the products and into the platform. So that's what sort of shapes the role of a solution architect. And it's not just about these technical parts, it's also about what do people bring as personal skill and attitude, right? We'll deal with many, many different situations and problems. So being flexible and eager to learn is definitely a great thing. But I wouldn't say that's just true for solution architects at AWS. That's probably true for any successful architect. The second one just as well, time management. If you do things well, you will suddenly be very popular, and maybe not in the way that you wanted to, but a lot of people want your help and have questions for you. So you need to be good at prioritizing and managing your time. You're expected to juggle many different things, customer engagements, contributing back to the platform, learning new things, helping and teaching, onboarding other architects, right? There will be many demands on your time. So managing that well is an important ingredient for success. Communication, complexity is our biggest enemy in all this, I often say, and explaining things well is the best antidote to complexity. So good communication, translating the levels, right? Why does a certain piece of technology, why does that make the best solution for your current business or enterprise or organizational strategy? right? Being able to communicate that, riding the elevator is actually extremely important. Then we also like to be decisive, right? In the end, it's not about just having grandiose models. You also need to tell the customer what to do and implement it, right? At some point, we need to pick left or right. And we like folks to be certified, to have credentials, right? I always say it's not sufficient, but it's a necessary precondition to show that you know actually your stuff well. It's like the driver's license. Guys, doesn't guarantee you're the world's best driver, but it makes sure you know the rules of the road and is absolutely expected from you. Now, if you're wondering, I was wondering why none of these guys have a mouth, and I found the answer is actually very easy. They work with the customer, they wear a mask, be safe, wear your mask. And with that, we're almost at the end, right? What I did want to share is that, of course, we don't invent all these things from new every time. As I said, we've done this thousands of times, so we have a huge body of knowledge. Yeah, and one of the most well-rounded of those is what we call the well-architected framework. All right, and again, that breaks down in pillars. There's a URL here, a lot of information about operational excellence. Again, it's not just tech, but it's also the ways of working. Of course, security is priority number 0 for us, and that is true for our platform, as well as should be at the customers. Reliability, nobody likes to pay for systems that are not actually running. So we have a lot of advice how to build reliable systems on top of the AWS cloud platform. Of course, we want to be efficient, right? Move faster without burning more fuel. As I said, software can actually do that. And then cloud gives you cost flexibility, right? The elastic pricing is amazing, but it also gives you the responsibility to deal with that. Right now, you can manage your costs, so you should actively do that. So of course, the well-architected framework also shows you how to optimize your cost. So there's quite a bit about being a solution architect at Amazon Web Services. Well, we have the tenants around it. We have a lot of good ideas what makes being a solution architect. And of course, there's a solid foundation those folks stand on, both on the technology side, right, the cloud platform, but of course also the frameworks around it that show how to build well-architected solutions at the customer side. Now, I hope this was an interesting sort of view across what it means to be an architect and how to think like an architect, right? Remember the sketches, the zooming, the different dimensions of things, right? I introduced the architect elevator, how you ride up from the penthouse down in the engine room, and good architects can cover that whole bandwidth. And then I shared a little bit about how a great role of being an architect in the cloud tech context is actually being an AWS solutions architect, because that's where the rubber meets the road, right? They work with the customers, they have all the power of the technology, but they need to make sure that they put it together so it brings the benefit for the customer, that it's secure and reliable and cost optimized. Now, there's a lot more to say about architecture, and I'm fairly active online. So I invite all you guys, follow me on Twitter, it's at GHOHP. I run my website, thearchitectelevator.com, and I'm actually probably most active on LinkedIn. So if you want to follow me there and comment and post questions, I'm always happy to see those. So thank you for your attention, and I believe we have some time for questions and answers. Thank you so much. Now I gave this great presentation, and the chat tells me there are no questions. How can this be? I should have added a slide which says, being a good architect also implies asking questions. So I invite everybody to not be shy. I think we have the questions through the chat, and I'll be happy to answer any of those. So maybe a question from my side for the moderator. Would I be seeing the questions in the chat? Okay, I'll give you guys a minute here. If I had known there's not that many questions, I would have talked a little bit more slowly. I was trying to get a lot of stuff across in a short amount of time, so hope folks are not overwhelmed. There's a question. See, there's a good question. My experiences in these kind of presentations is folks are often shy to ask a question, but then the questions that come are actually fantastic. So here's a question that is actually very good: is any best practice of architecture iterations? Great questions and interesting topic, right? It's in a sense, I mentioned earlier that I have a chapter in my book that is architecture gives you options. And just really quickly, what that means is, of course, we can't really predict the future, but we want to be able to be agile, right? We want to be able to deal with different things that come along in the future. So the way you do that is you build options in your software, right? This could be the option of horizontal scaling. So if load goes up or down, perhaps, right, your architecture can deal with that. That is a great way to have an option. It's a great way to defer a decision. Now, you cannot anticipate all the options that you need in one run. And this is where the iterations come in. Because I think there's a second very important part in building good architecture that I didn't speak to. That's why I liked the question. And that is building feedback cycles. Right? When we see success stories, some business or any kind of team has done something that worked really well, we're sometimes led to believe that this was sort of one shot, right? They did something, it was like, look, oh, here's Instagram, right? And they sold it for $1 billion or whatever the story is. It's never that way. It's always been done in small iterations. And the reason we like iterations is because they give us the ability to react to feedback, right? Rather than trying to predict the far future for like the next 10 years out, right? If we make iterations, maybe we have some feedback in a couple of weeks or maybe a month, and then we can learn from that. Now, how does this play back into architecture? I would say in a couple of ways. The one way is it influences a little bit the options that you need to have in your architecture, because you can have a smaller horizon, and that makes predicting the future easier. And that has a good advantage because these options aren't free. So having a shorter horizon means you might need fewer options, and that means you can build a less complex solution, because the price for these options is generally complexity. There's a second aspect, and the second best practice of working iterations is the biggest danger of working iterations is losing velocity. Right? You keep adding and changing and patching a little bit here, and at some point the thing becomes a giant mess and grinds to a halt. And that's why I often say that agile environments, the ones that work very much in iterations and course correct frequently, they're actually very much in need of architecture. You'll find people say, oh, we don't need much architecture because we're agile. No, it's completely the opposite. Because you're agile, you have a high rate of change. And we already learned that a high rate of change is when architects engage. So the second part of being an architect in an iterative environment is to build a system that can sustain the velocity. That sometimes means that you refactor and fix things and restructure. It can also mean that you localize changes, a great architecture principle, so that a change doesn't ripple through the whole system, but a change can be done locally. So if you have one iteration, you change here, you have another iteration that changes there. There isn't a lot of crosstalk between the two. That I would say is the second great part of how architects can contribute to a highly iterative environment. Last comment I would make is that some folks also talk about evolutionary architecture, like does the architecture itself iterate? And the real answer is, of course, it does, but it doesn't do so at the same rate of change. Like a good architecture needs to reasonably anticipate what's subject to a high rate of change and make that easy to do and isolate it. And underneath are some decisions. They're never eternal, but they need to have a lower rate of change. Even if I say like, okay, I'm going to build things on a VM, right? I can move to containers at some point. I can move to a serverless environment, perhaps, right? I can change my architecture, but that's not something I do 50 times a day. Like software releases and fixes and builds, I do 50 times a day. So I think it's very good as an architect to have a very clear view what are the delineations of rate of change between your major pieces, and make sure that they roughly evolve at those rates of change. Like if your base platform moves faster than the stuff on top, then you have the cart before the horse, like you will have a lot of problems. So yes, architecture will also evolve, but generally much more slowly, and that is actually a good thing. Now the questions come in. Hold on, can you please, I'll read the questions out. I think that's most helpful. Can you please share about past lessons and practices to achieve global optimization versus local? Yeah, I have a lot of scars and a lot of battle stories today, so I try to make it short. I would say achieving total global optimization is not easy. If I would say at Amazon, we're quite good at it actually, but I'll give you some hints, right? The most important part that I find is transparency. Like if there's intransparency, like if each department only sees what they're doing, and then sort of they have a API around it, which in a sense is a good thing. But if there's no transparency in how they work internally, it is very difficult to optimize end to end. And you see this both in systems as well as in organizations, so technical systems and organizational systems. So I always say transparency is number one. Number two for me is aligning it with a business goal or business value. The purpose of your system, no matter how much it's hidden, like you might be the service directory, the service mesh, the container framework, scaling something, at the end of the day, you are there to help the business. If the business never scales, you don't need a scaling component for your Kubernetes cluster, right? So everything ultimately relates back to a function that measures value in business. And that is a great way to align the optimization functions, and it's much more likely to lead to global optimization. So I would say after the transparency, having the common objective and a value-driven objective is number two. And number three is what we exactly talked about, feedback iterations, right? You're not going to get this right the first time around. So being able to iterate is actually a critical component. So and I think at AWS, we have great examples of that, right? The two pizza teams, they each have a fitness function, right? They evaluate it by how they do and contribute to the end-to-end flow. And what we look is very much the end-to-end transparency. And that probably comes out of our core business, because I often say, if a package is delivered 99% of the way, like it was on the truck and the driver had it in his hand or her hand and almost put it at your doorstep, the customer gives us a score of 0, right? Almost done doesn't work for us. It has to be optimized end to end, whether it's the inventory managing, the packing, the shipping, the transportation, the electric trucks, the route optimization, right? It all only counts when the thing is on time, on the doorstep, or in the customer's hands. So I think that is the reason we always have a strong focus on global optimization, and all the things I just mentioned are very much baked into our operating model. Great question. So here's the next one. So I'll read this out. Often it is mentioned architecture should be resilient and available. Would you see one? Oh, would you see one, or it would be sufficient? Oh, now I need to guess a little bit. Hold on. It's mentioned architecture should be resilient and available. Now, okay, if you're asking me to comment on the two terms, is availability is the outcome, right? The system is highly available if it has no unscheduled and actually no scheduled downtime, right? That's the definition of availability. It's uptime, right? The thing is running 100% or 99.99%. I think resilience is a way to get there, right? You could try to get there with a robust system. If it's 99%, you might make that. If it's 99.99, probably not, right? That's why we have multiple availability zones physically separated everywhere, right? So the resilience for me is the mechanisms to get to the high availability. So I hope that catches the question. If not, I invite you to go back in the chat and I try to catch it. Do you think TOGAF is still relevant? So the big architecture frameworks and enterprise architecture frameworks. Honestly, personally, I have mixed feelings about that. I think if you're not sure sort of where to go and you need a starting point for architecture, the frameworks are helpful. If you sit in front of the canvas and you have writer's block and you're not sure what your architecture should be doing and not doing and how it should be contributing, I think the frameworks are actually quite useful. But to me, they are the starting point, right? The framework is something general, and each organization's needs are going to be different. Your problems are going to be different. Your biggest problems are going to be different. Your constraints are going to be different, right? You need to customize what you do. So that would be comment number one on top of this common framework, right? You need to adjust and be ready to customize. You can't just follow the framework to the T and sort of expect that to be a great outcome. The second one, and it's related to customization, is I think you need to place an emphasis. Like a lot of these frameworks, they make sure that everything is in, and that certainly has value, but you can't do everything at the same time because you probably do a mediocre job at everything and you're not going to get very far. So you need to pick a conscious emphasis. Like, what is the biggest problem? Like when I was in financial services, the biggest problem that I felt we had is it took us too long to deliver software. And I often say, if you can't do that, all other problems become secondary, because if you can't put new software out, all great ideas you can't implement. If you need to security patch something, you can't do because you can't deploy the new thing. So getting software into production to me was the most important thing, and that's what we initially worked on. Right, and once you've done that, you can go to the second problem. Right, I like analogies, so I'm going to make up one on the fly a little bit. I think the frameworks, they're like a city map. Right? They give you the lay of the land. You see what is all available, and that is really helpful. But a good sightseeing tour is a lot more than a city map, right? You don't just like go sort of crisscross every street. Like you look at what's most interesting. You course correct, something unexpected happens, positive or negative, right? Your actual path is going to be quite different, and you might sort of make your own version of the original map. Maybe that's a useful analogy to think about. A good starting point, but really a starting point for your version of architecture, not to be followed mechanically, would be my advice. Oh, what are your views on IM8? Well, I don't work for GovTech anymore, so I don't think I know what IM8 actually is, right? So backing up so a little bit, let's say the question vaguely relates to a governance document that describes how IT processes are supposed to be implemented, just as an assumption. So governance is an important function in any large organization. There's just no way around it. And for many different reasons. The most unexpected reason is probably that a common baseline actually enables more autonomy. Right? People often think like governance is something that takes freedoms away or flexibility away. It can actually enable flexibility, because my slogan here about autonomy, not anarchy. If everybody does what they think is best, that's anarchy. Ask the anarchist. Like, think they do the best thing, but the other people don't. So anything that's autonomy has a common baseline underneath, a common platform, right? So having some governance, some prescription, sort of some overall bounding box is good for many things, including actually autonomy, right? So it's often overlooked. So that's point number one. Now here comes the catch. Architects, we always know about the catch. The good intentions that are baked into these frameworks, they have to be translated into some mechanism, right? You say we want to protect our citizens' data, we want to be highly available, right? It's all like great things. We want to be compliant with any regulations, right? This is where these governance frameworks usually start, and they're all good things, right? We want to be cost efficient, spend taxpayers' money wisely, right? All great stuff. Now they get translated into certain mechanisms, and they get translated into those mechanisms by the available technologies and the existing constraints, right? The technical constraints, but also organizational constraints. And here's where I see some of these frameworks run into trouble. When the constraints change, like, we're a great example of loosening up constraints. One of my favorite slogans about cloud is it makes some constraints go away. It's no longer speed or quality, it's speed and quality, right? You no longer have that constraint. And there's many other constraints we can make go away. Scaling, we make go away, right? We make many constraints go away. What happens is you cannot just take this translation and apply it to the new world with fewer constraints, because you already baked the past constraints into the mechanisms that you translated into. I'll give you a simple and sometimes contentious example: audit. Right? You say we need to have compliance with X, Y, Z, so twice a year we do an audit. Now, the assumption or the constraint that baked into that is that transparency is low. Because if you had full transparency, why do you need an audit, right? You could go anytime and look and see everything. So when you go to an environment that brings you more transparency, to just stay with that simple example, you can't sort of remap this. It's like, oh, we do the audit maybe every quarter, right? That's not how it works. You need to go back to the original intention. For example, make sure everybody follows the common guideline. Like say, everybody needs to build resilient systems, right? Let's say that's what we want. The old translation might have been audits. We look at your system architecture, make sure it's resilient. Maybe we do a test. The translation in the new world, if you go back to the source and retranslate, is the chaos monkey, right? The chaos monkey, you guys know from Netflix, right? The basic chaos engineering. It just like takes down system instances in your environments. You're choosing whether production or pre-prod, but it basically just takes down environments. Now that is the modern translation of the same requirement, because it makes sure all systems are resilient, because the ones that aren't never make it in production because they basically get wrecked before that. But this is not something you come back from doing a periodic audit to the chaos monkey. You have to go back to the original intent and retranslate. So hopefully that sheds some light on these kind of governance frameworks. They're there for good reasons, often for reasons that you might not think about, like autonomy. But when the environment changes, you need to go back and retranslate. In my experience, there's no shortcut you can take there. And that's where a lot of friction. When I see friction with these frameworks, is somebody having done the translation and now the environment changed and they try to sort of adjust. I've never seen that work. I've always seen this to a lot of frustration. So going back, retranslating seems like a detour, but it's actually the only viable way to really understand how to use the power of the new technology to achieve what the framework's original goal was at some point. Cool. Now the questions came trickling in, so I need to scroll back. Continuing from the last question on resilience availability. Okay, so thanks for the clarification. Is mentioned a need to move into site reliability engineering, and would be going to SRE means higher resilience leading to higher available system. Yeah, so site reliability engineering, great practice, right? We talk about architecture being technology, but also being practices and ways of working. So I actually worked at Google as a software engineer way back when the first SREs were recruited. I almost volunteered to become one. In the end, I went to Japan and did other things. So I was right there at the birth of the SRE, and I could actually see what problems they solve. So what I would say is, like most of these things, it's not a magic solution where you give somebody the SRE title and your system is more available. But I think what it does is a couple of things. The first thing is, the original definition of SRE was to bring software engineering practices to operational concerns. And I think that is still a great thing. Now, we made enormous progress since back then. It was like 2006, maybe, when this started, right? Our systems are much more powerful and capable, but it's a software kind of mindset, right? If I can automate it, I automate it, right? If I can script it, if I can make it repeatable, right? If I can have automated triggers, basically, I try to make as much as I can of software problems, because software is fast, repeatable, reliable, right? I think that is still very much behind the SRE movement. Now, in terms of availability, it's an interesting story, and I try to be brief here, because the goal of SRE is not to make a system 100% available. The goal of SRE, and you guys know this around your service level objectives and error budgets, the goal is to find the right balance between system availability and rate of change. Now, I said you can be moving fast and having high quality, right, for your software builds and if your software deploys, but you might be releasing a feature that's unpopular, right? That's also a bug of sorts, right? Or something in the environment change, like day zero exploit, right? Many things can happen that impact your availability. So I wouldn't take the goal of SRE as like, I just ratchet up the availability until like how many ever nines, but rather how many nines are right to me. And to realize that when I'm below, everybody should work in operations, like it should be everybody's job to increase the system availability, right? And you slow down feature delivery and you get back because the error budget is consumed. But also, if you're above, it means you should speed up a little bit and people should be pumping out more new features because error budget is there to be used. You don't get a reward for having a lot of error budget saved up. So in the end, the way I like to visualize this is when you look at a traditional availability picture, the green is always on the right side. Like the more nines, the greener it gets. One of the key tenets of SRE, the green is where your service level objective is. And below is certainly red, but above it's also orange/dark orange. So I hope this sheds some light, right? I think the software thinking into operations was one of the core ideas. It's become fairly pervasive now with all these automations, software-defined infrastructure, all these kind of things. So a lot of that has become just normal, and that's great. And the thing around availability is not, more is greener, but it's like know what your target availability should be and make it the whole team's job to achieve that. Like my favorite slogan for SRE is, if your air budget is exhausted, everybody's in operations. Right? The development team can say, oh, it's like operations problems. Now you are in operations now as well. So I think that's the most powerful way maybe to look at SRE. And that is also a big jump for teams. So I would apply that test, right? It's like, if your air budget has a lot left, are you willing to speed up and maybe sacrifice availability? If the answer is no, you haven't embraced the SRE thinking, and vice versa. If some people believe they're not responsible for operations, you probably also haven't gotten there. So it's actually quite a high bar, but if you get there, it's an amazing way. It's an amazing way of working. Oh, like you guys, you guys giving me flashbacks now. It's like, what is your view on GovTech AI? AIAS, I already purged that from my short-term memory. How to address performance issue if the app needs to go through so many layers. Oh gosh, I used to have many strong opinions, right? I remember the key thing of AIAS is, of course, I know nothing, right? But if I was going to work there, what I would know that it's about layering and making multiple hops, right? And I think having degrees of separation can make things manageable and controllable. The key thought I would have to that is that I thought a lot of these mechanisms, they're still very much based on sort of IP level routing. And at the end of the day, it gives you relatively limited flexibility. So, or also relatively little resilience in sense, because a lot of stuff can go over an IP connection. So I think some of the architecture patterns of preferring to have a certain separation, we do this in the cloud, we do this with subnets and VPCs, right? But at the same time, there's sort of different levels at which you control. It can be a service mesh, right, where you do traffic routing. So my guidance would be, remember when I showed robust versus resilience? Robust is just infrastructure, and resilience is infrastructure application. My advice would be for these frameworks, don't try to solve the problem just at the infrastructure level, at the IP level, right? You have much more available to you at the application layer and make that part of the solution. Advice number one. Advice number two, not all problems have to be prevented upfront, because you'll never be able to predict all problems anyway. So my second advice would be increase transparency and monitoring and operation resilience, so you can detect faster if something goes in a way that you don't like, and that can balance out very nice. So there's some things you design into basically making them not break or difficult to do wrong, but then also you want to have the transparency, the ability to react for things that you didn't design for, because you'll never be able to do that. So I think that frameworks like AIS have a role there, but it's one piece in a larger context. Hopefully that helps. And I think we look in the time here, probably the last question here. Please share recommendations to make security systemic within the application of building cloud-ready application architecture. Ooh, that's probably not a two-minute question. Couple of things, just really quickly points, right? Security is always shared responsibility, right? You cannot look to somebody else to make things secure for you. And that's in the AWS shared responsibility model. We go right up front and center, right? We can do many great things for you, but it's hard for us to make a really vulnerable software super secure, right? You need to do your part. We do our part. I think that's a big part of it. It's everybody's job. And I think once you have that assumption, right, there's a lot of things about shifting left and DevSecOps and bringing security concerns earlier into the life cycle. I think that generally has a lot of promise. There's one important aspect. You don't want to introduce friction, right? If you shift left things and you slow things down earlier rather than slowing them down later, you actually haven't gained anything. And I think software allows us to detect problems earlier without reducing friction. And that's actually the way I would look into sort of the shift left, so-called shift left maneuvers, bringing security early in the life cycle without introducing the friction. That slowing things down isn't a great security strategy. Well, this was a lot of great questions. Do we have any more Any more time? I believe we're near the end of the session, actually. Looking for the moderator to give me a hint here. Great. So we'll wrap up here. I thank you guys again for listening and for asking the great questions. It was really fun. Thank you for your time.